Can you all switch on the camera? Let's start the class. Today we are going to revise the chapter Polynomials. So what all things we know about polynomials? I just give you a quick revise and then we can... Okay, Avantika, I've seen your message. Okay, so we can start the MCQs. So before that, I would like to just revise what all things we learned. Have you all saw the synopsis? A revision class? No? Okay, polynomials we already studied, right? What is a polynomial? Can you give an example? What all things we know about it? Tirtha. Who is going to tell Tirtha? Is gone? Okay, Vaiga. Oh, what is a polynomial? So polynomial is consisting of variables, coefficients, that is constant term will be there, coefficients will be there, and general formula can be written as polynomial p of x can be written as a1 plus or a plus a1 x raised to 1 plus a2 x raised to 2 plus a3 x raised to 3 plus etc. up to an x raised to n. So the powers of x, that determines the degree. So there are linear polynomials, quadratic polynomials, cubic polynomials, etc. It depends upon the highest power of the variable. The polynomial in x, how will you determine the degree? For example, x square plus 3x plus 4. Here this is a quadratic polynomial. The degree is 2. How you determine the degree? By looking at the variables, look at the highest power. Here it is 2x square. So the highest power says the degree of the polynomial. X plus 3. This is also a polynomial. We call it as linear polynomial. Linear means power will be 1. It will represent a straight line. In grade 9 we have learned it, right? So linear polynomial will be a straight line and a quadratic polynomial will be a parabola in shape. Then a cubic polynomial, x cube plus 3x plus 4. Highest power is 3. So this is a cubic polynomial and the shape will be like, we know x cube, the graph of x cube and all, it will be like a curve, right? And so these are the polynomials that we all know. Linear, quadratic and cubic and all. And what all things we learned about polynomial? Polynomial have one particular rule. What is it? It is regarding the power of the variable x. The power of the variable must be whole number. It cannot be a negative number. Whole number it should be 1, 2, 3, 4, etc. Remember that the power of the variable x should be always whole number. So n is whole number. And how about the other numbers? a1, a2, a3, etc. an? a1, a2, etc. All these constants, the coefficients can be? That can be any number. Any number means? It can be real numbers. It belongs to the real number system. Okay. Real number. And what all things we learned about polynomials? We were discussing about zeros. What is the meaning of zeros of a polynomial? Zeros means if you give, that means p of x is our polynomial. What is the zero of the polynomial p of x? Any number, let it be k. If k is a 0 means if you substitute x is equal to k, you will get the value is equal to 0. The value k which will give p of x is equal to 0. That means p of k is equal to 0. That value is known as 0. Right? And number of zeros. What is the meaning of number of zeros? So zeros can be like, how many zeros will be there? Number of zeros. That is also important. First thing, if it is a linear polynomial, ax plus b, that means an x will be there with the power 1. there can be a constant term. So ax plus b is a linear polynomial. So this will be a line. Now graphically, I'm just giving a quick revision only. That's why I'm going so fast. We have MCQs, but this is important to revise. That's why I'm telling you this. So listen very carefully. We are talking about zeros. What is a zero of a polynomial? Graphically, zeros means if it is a line, ax plus b is a linear polynomial. So it will be a straight line. Okay, we know how to draw a line. Straight line you can make. And that line will be intersecting the x-axis. It is crossing the x-axis at some point. Right? That straight line will cross the x-axis. That point where this line is crossing the x-axis. For example, it is 3, 0. So only x-coordinate will be there, y-coordinate will be 0. That ordered pair will be the root. That is x is equal to 3 is the root. You know the root? That is zeros. We call it as zeros. Root is a little bit different, that we will learn about quadratic equation. Zeros. What is a zero? Zero is a point where this graph will cross the x-axis, which will intersect the x-axis. The point of intersection in the x-axis is counted as zeros. Since it is a linear polynomial, you will have 1, 0. Only 1, 0. It will cross the x-axis only at one point. Right? And what if it was a quadratic polynomial? Ax square plus bx plus c. If it is a quadratic polynomial, this can be a parabola. Okay, so the parabola can be upward or downward depending upon the value of a. If a is greater than 0, the parabola will be upward direction. If a is less than 0, the parabola will be downwards. How many zeros will be there? For a quadratic polynomial, how many zeros? It is not necessary that it is 0. 2 zeros will be there. Maximum 2 zeros. That means maximum point of intersections in the x-axis will be 2. That means if I am taking a greater than 0, the parabola can be like this. Now the parabola is meeting the x-axis at 2 points. Okay. And for a greater than 0, the parabola can be upward, but the point of intersection of x-axis is only 1 point. And for a greater than 0, the parabola can be upward direction without even touching the x-axis. So for a quadratic polynomial, you can have 0 zeros, that means no zeros at all, that is it is not touching the x-axis at all. And 1 0, that is point of intersection is only 1 point. And 2 zeros is also possible. How? When the parabola is crossing the x-axis at 2 points. So this is the meaning of zeros. Understood? Keep it in your mind. Even if you are having a cubic polynomial, cubic. So it will be like ax cube plus bx square plus cx plus d. And this is a cubic polynomial. This is standard form. It is not necessary that all the other terms are present, but it is compulsory that the term along with the x cube is there. Okay, clear? Now, how many zeros can be there for a cubic polynomial? Yes, at most 3 is possible, and there can be no zeros also. Okay, but the thing is that at most 3. But this is particular case is quadratic polynomial. This is very clear since it is parabola and all. And you can check your textbook also. There are graphs given. So if I am giving you an example, here that graph is crossing the x-axis at only 1 point, and sometimes it can be like, now what? It is crossing at 1, 2, 3. That means there can be 3 zeros also, etc. So you got the idea of zeros. The concept of zero is clear. Now the next thing is, if you have ax square plus bx plus c. Let us start with the linear polynomial ax plus b. The zero, you can find the zeros using the coefficient also. How will you find the zero of a polynomial using the coefficients? It is minus b by a. That means the value of x for which this value becomes ax plus b becomes 0. The polynomial becomes 0 is minus b by a. Minus b by a. Okay. And for a quadratic polynomial, how do you take? Minus b by a, which is the sum. And c by a is taken as the product. So let me ask you one thing. What is the difference between zeros and roots? We use these terms, right? Zeros and roots. Zeros means this polynomial will become 0. The value of a constant which we will substitute for the variable x. Root means ax square plus bx plus c is equal to 0. Now this is an equation, quadratic equation. For this equation, whichever values of x is going to make this equal to 0, that is known as the roots. There is a slight difference, and this roots, when you are having roots, we take alpha and beta as the roots of the quadratic equation. If it is quadratic equation or quadratic polynomial, we represent alpha and beta as the different roots. And how do you take? We learned that sum of the roots alpha plus beta can be taken as minus b by a, and alpha into beta can be taken as c by a. What is this a, b and c? A is the coefficient of x square, b is the coefficient of x, and c is the term independent of x or known as constant. So these are the important things you need to know before you are going to crack the MCQs. So shall we start?
Yes, ma'am.
This is very quick revision. So let's go to the questions. It's very easy. If one of the zeros of the quadratic polynomial x square plus 3x plus k is 2, then value of k is. So the 0 is given. One of the 0 is 2. So if 2 is a 0, what we can do? You just find p of 2 and that will be equal to 0. P of 2 means you just substitute instead of x, you give 2. 2 square plus 3 into 2 plus k, that should be equal to 0. So 4 plus 6 plus k is equal to 0. K plus 6 is equal to 0. Therefore, k is equal to minus 10. So you will be bubbling option B. Isn't it easy? Next one.
Yes, ma'am.
Now you read this question and tell me. I will ask one person. You need to take only 1 minute to crack this one, okay? There will be 3 levels of MCQs. All the questions will be of 3 different levels. Easy questions will be there, medium level will be there, higher order thinking, that is hard type, difficulty level will be there. You need to just little bit more, you have to think about it, then you can crack it. Now look at this question. Sum and product of zeros of a quadratic polynomial, so the power is 2, are 8 and 12 respectively. Then their zeros are, isn't it easy? Sum is equal to 8, product is equal to 12. You need to find 2 numbers whose sum will be 8 and the product will be 12. Did you get the answer? Who is going to press the buzzer first?
Option A.
Yes, dear?
Option A.
Option A, 2 and 6. Yes, you are right. Sum is 8 and product is 12. Okay, this is an easy level question, so you can crack it within 1 minute. Okay? Anybody is having any doubt, please ask. Okay, Gifty, Leah and all. Okay? Next question. The value of k such that the polynomial has sum of its zeros equal to half of their product. So we have a polynomial, but it is given in terms of k, and they says that the sum and the product is connected. How they are connected? Let us consider the sum as alpha plus beta, and the product is alpha into beta. And they are saying that alpha plus beta, the sum of its zeros is equal to half of the product. So alpha into beta divided by 2. Alpha plus beta is half of alpha into beta. Is that clear? Okay, now what is alpha plus beta? when you have a quadratic polynomial, you can take the sum and the product. How can you take it? Alpha plus beta is minus b divided by a, where b is the coefficient of x. By looking at the quadratic polynomial given here, what is the value of b? B itself is minus of k plus 6. Are you getting my point?
Yes, ma'am.
Okay, so if your quadratic polynomial is ax square plus bx plus c, then our alpha plus beta will be negative b by a and alpha into beta will be positive c by a, right? Now, looking at this, negative b by a. So, negative of b itself is a negative number, negative of k plus 6. And please don't forget to put the brackets whenever it is required. A is 1. So, you will get minus of minus k plus 6, but k plus 6 is inside the bracket, look. So, if you are not writing the bracket, it will be minus k minus 6. But it is obvious that minus of minus is plus. Am I right?
Yes, ma'am.
Next, alpha into beta, that is product of the zeros. That is taken as c by a. What is c here? 2 into 2k minus 1. 2 into 2k minus 1, that is c, by a. A is coefficient of x square, which is 1. That's why I am not writing it there. Now we have alpha plus beta and alpha into beta. Okay. Now what we do? Now we have a connection that alpha plus beta is equal to alpha beta divided by 2. Half of the product. Am I right? Now what we can do, that implies k plus 6 is equal to half of the product. 2 into 2k minus 1 divided by 2. So these 2 and 2 get cancelled. So I get k plus 6 is equal to 2k minus 1. So if I am rearranging, I will get k is equal to 6 plus 1, which is 7. 6 plus 1, which is 7. Am I right? Did I make any calculation mistakes? Yes, very good, Vaiga. Your answer is correct. Okay, anyone else? Jenny Maria? Since each and every minute is important, I can't call you and like. Is it clear to you, dear? Jenny, are you there?
Yes, ma'am.
Is it okay? Abhinav, Harinarayan, are you all listening? Please switch on the camera so that I can see your beautiful faces. Hari, Alok, Gopika, please switch on the camera. Read the next question also. Mohsen, at least you will switch on the camera, I think. Thank you, Neha and Vaiga, for not leaving me alone over here. Okay, then listen. Let's see the next question. Okay, Hari, it's okay. I hope you can listen to the class. Okay. The quadratic polynomial, again it's a quadratic polynomial. Sum of zeros is minus 5. So sum alpha plus beta is equal to minus 5. And the product is 6. Alpha into beta is equal to 6. Then the zeros will be? No, we don't need the zeros. We need the polynomial. So how will you write the polynomial? Alpha plus beta. So how do you get that? We know that sum is, it will be like ax square plus bx plus c. This is a quadratic polynomial and the sum will be a. Alpha plus beta is b by a minus b by a and alpha into beta is positive c by a. So when you have these numbers, if you are getting confused and all, you can just do the factorization also. No? Minus 3 and minus 2. So you will write it as x minus 3 into x minus 2. So the sum will be like the product will be positive 6, first term will be x square and the middle term will be minus 5x. Okay, so that means x square minus 5x plus 6. But always try to write the factors and then come to the polynomial. Not always it will be directly if you write, sometimes it can get wrong. So please make sure that it is correct because alpha plus beta is not directly the midterm all the time. It can be having some coefficient for the x square term also. So make sure that everything is in proper place. Now this is an easy question. So we got that x square minus 5x plus 6 is the what? The polynomial. Clear? Somebody said it is A. Is it A?
No.
Am I right? Since we have alpha plus beta, that means sum of two roots should be minus 5. And the product is a positive number. If the sum is a negative number and product is positive, means both the numbers are negative. So it is 3 and 2 with the negative signs. So the factors will be like x minus 3 into x minus 2. And when you open the bracket, you are getting x square minus 5x plus 6. See, all the options are like very much similar, right? So you will get confused. So don't look into the options and get confused. Always go through the theory, the theory part which is thorough for us. Okay. Next.
Ma'am,
Ah,
I have a doubt in that.
in the last question.
Ma'am, I have done using an equation.
This question.
Yes, ma'am.
Okay.
X square minus sum into x plus product.
Ah.
So while using that way, I got x square plus 5x plus 6. Even I got that also. Yeah, you got that one.
X square plus 5x.
Yes, ma'am. Option.
But the sum of whose zeros is minus 5. Sum of zeros is alpha plus beta. Right? Alpha plus beta should be. The option is it option A? No. It's like, see, when you have the sum, it is x square plus minus of sum, right? Minus of into x plus the product. Isn't it the way we normally write it?
Yes, ma'am.
Okay, but here, no, it's not the way. Okay, let us go through the theory part. Did I made any mistake in that? Sum of two numbers is minus 5. Product of two numbers should be positive 6. Then what are the roots? The roots will be minus 3, minus 2. So, x minus 3 into x minus 2 is equal to, so okay, sum should be minus, okay, sum should be minus b by a, right? So, okay, yes, you are right. The option is A. Sorry, I made the mistake. Yeah, it is like minus of sum plus product. So, it is minus of minus 5. So, plus 5 plus 6 it is. Then only you will get sum is equal to minus b by a, which is minus 5, and the product is equal to c by a, which is 6. Yes. Sorry, my bad. Yes, we are right. Okay, all set? Any doubts? Thank you, Vaiga. Okay. Okay, next one. Alpha and beta are zeros of a quadratic polynomial x square minus 5. Then the quadratic polynomial whose zeros are 1 plus alpha and 1 plus beta is. Okay, so we have a quadratic polynomial x square minus 5. And the alpha and beta are the roots. So if alpha and beta are the roots, how can we write? We need to find polynomial whose roots will be 1 plus alpha and 1 plus beta. Now what we can do is, how will you find the roots? So we can write like x square minus 5 is equal to 0. So x plus, this is a square minus b square form, right? So x plus root 5 into x minus root 5 it will be. So the values of x can be plus root 5 and minus root 5. And when you substitute that values for x here, x square minus 5 will become 0. That means the zeros are, right? So the zeros are root 5 and minus root 5. Am I right? Am I right? So that means the roots alpha and beta are root 5 and minus root 5. Alpha and beta are zeros of the quadratic polynomial x square minus 5. So we got what is alpha and what is beta. Right? Now what we need? What is 1 plus alpha and 1 plus beta? 1 plus alpha and 1 plus beta. That means we need to find a polynomial whose roots will be 1 plus alpha and 1 plus beta. Right? Now we have Alpha, if you are taking alpha is equal to root 5 and beta is equal to minus root 5, the new roots will be 1 plus root 5 and 1 minus root 5. The new zeros. Now we need to find a polynomial whose roots will be this one. So how can we write it? When you have zeros like this, the formula will be like x square minus sum into x plus product. Am I right? So it is x square minus, what is the sum? Now this is the new root, alpha 1 and beta 1. We have already given a quadratic polynomial whose roots are alpha and beta. And by our knowledge, we found that what are the zeros of this quadratic polynomial x square minus 5. For that quadratic polynomial, root 5 and minus root 5 are the zeros, possible zeros. Because when you give those values, this is going to be 0. The polynomial is going to be 0. Is that much clear? Now we found the value of alpha and beta. Now we need 1 plus alpha and 1 plus beta. So that could be 1 plus root 5 and 1 minus root 5. Now what we need? We need sum. Sum of the roots. Sum will be 1 plus root 5 plus 1 minus root 5, which is equal to 2. What will be the product? Product will be 1 plus root 5 into 1 minus root 5. 1 minus root 5. A plus b into a minus b. So a square minus b square is equal to minus 4 I got. Am I right? Now what could be the polynomial? X square minus sum is 2x plus the product is minus 4. I got x square minus 2x minus 4. It's not given in the solution. So what is the value? What is the answer? None of this.
None of these.
Okay, clear? Clear, Abhinav?
Yeah, ma'am.
Next. It's not just because Abhinav told yes. I just want to move forward the class. We have a list of... Yes, Alan? You can ask. Any doubts? Writing. Okay, sorry. Actually, once you start cracking these questions, you will get an idea how to approach the questions from this particular chapter, polynomials, how this the logic is working. Once you get that one, you can solve whatever questions we get because the same pattern will be there. Okay, can I go to the next one? Yes, Gobiga, you have anything to say? You raise your hands, that's why I'm asking. Gobiga? Can I go to the next one?
Yes.
Okay. Now, we have two statements here. From here onwards, we have a couple of questions. Not couple. We have a few questions, which is like we have a statement, two statements given, S1 and S2. We need to assess the questions like the given statements and we have to make sure whether it is true or false and we need to pick from the below options. And the options are like S1 is true and S2 is true. S1 is true but S2 is false. S1 is false, S2 is false. S1 is false but S2 is true. That means we have to find out which all statements are true and which one is wrong. Okay, whichever is false and true and all. Then we can choose from the given option. So shall we try the first question?
Yes, ma'am.
X square plus yes,
S1 is true, then S2 is false.
That means if the first statement is correct, but the second statement is wrong, then you have to choose the option accordingly. But before that, we need to check whether the statements are true or not. So how about the question x square plus 4x plus 5 has two zeros. Two zeros. Is it right?
Yes, ma'am.
We learned that it is not necessary that it should always have two zeros. If the statement was it has at most 2 zeros, yes. Yes, second statement is true. A quadratic polynomial can have at most 2 zeros. That is completely true. But before concluding this one, you need to check whether you have 2 zeros or not. So let us look at the quadratic polynomial x square plus 4x plus 5. How will you find the roots? You need to find sum of the roots will be like sum of the zeros will be minus b by a, which is minus 4, and the product will be 5 by 1, which is 5. Now you need to find two numbers whose sum will be minus 4 and the product will be 5. Can you find such numbers whose sum will be negative but the product is positive? Okay, if the product is positive means you need to find two negative numbers, isn't it? Isn't it the way we think about the numbers, right? So when you are thinking about it, sum is equal to minus 4 but product should be 5. Is that possible? Minus 5, minus 1, no. It will be minus 6. Minus 1 and minus 4, then sum will be minus 5, no? 1 and minus 5, then the product will be negative 5. Minus 1 and minus 4, not possible. Then any other choices? Sum should be 1 and minus 5. We checked, not possible. When 1 and minus 5, when you take the product, it will be minus 5. Product is a positive number. So can you find the root? Actually, there is no root for this one. So this is a parabola which will not touch the x-axis. Since a is greater than 1, a is greater than 0, a greater than 0, it will be open upwards. So this is a polynomial, quadratic polynomial. It's a parabola, but it will not it will not intersect the x-axis. So no roots. So S1, it has 2 zeros means S1 is not true. So S1 is false, but S2 is correct. So S1 is false, but S2 is true. Understood how to find the answer? So do not conclude that it's a quadratic polynomial, so it will have 2 zeros. Not necessarily. Understood? Next. S1, the factor of 3 by 2 x square minus 8x minus 35 by 2, the factor of this quadratic polynomial is 1 by 2 into x minus 7 into 3x plus 5. The factor is calculated by dividing the coefficient by 2 and expression is obtained by splitting the middle term. The factor of this quadratic polynomial is, okay, so when you have the factors, what are the factors given? 1 by 2 times x minus 7 into 3x plus 5. Okay. So is it a factor? Is it the factor? How do we check whether this is a factor of this? So just simply open it, no problem. We can simply open it up. What will happen? 3x square plus 5x minus 21x minus 35. Outside the bracket 1 by 2. Now 3x square minus 5x and 21x is like 16. 16x minus 35. It's 15x. X into 3x, 3x square, 5x minus 21 minus 35. Correct? And divided 1 by 2. Now what happens is when you take the 2 inside, it is 3 by 2 x square minus 8x minus 35 by 2. So it's the correct answer. So first one is true. And now they are saying that the factor is calculated by, the factor is calculated by dividing the coefficient by 2. Dividing the coefficient by 2 and expression is obtained by splitting the middle term. How do we find it? What did they say? Factor is calculated by dividing the coefficient by 2 and expression is obtained by splitting the middle term. Was it so? Expression is obtained. Factor is calculated by dividing the coefficient by 2. Yes, all the coefficients are divided by 2. Okay. And expression is obtained by splitting the middle term. How do we factorize this one? When you have a quadratic polynomial, how can we factorize? When we do the splitting the middle term, what we do? You forgot. Splitting the middle term method. We take the middle term, not the elimination method. What do we do is we split the middle term. How? We will look at the coefficient of x. We will take the half. That means divided by 2. Then we will square it and add and subtract. So is it correct? Obtained by splitting the middle term? Yes, of course we are splitting the middle term, but factor is calculated by dividing coefficient. Coefficient of what? It is not given properly. The coefficient of x is being divided by 2, isn't it? Half of the middle term is taken, dividing the coefficient by 2, and expression is obtained by splitting the middle term. But it is not clearly said, right? That statement, do you feel that it is a right statement?
No.
There is something missing, right? But the first statement is correct. So let us choose what? S1 is true, but S2 is false. Because it feels incomplete, isn't it? Can I go to the next question? Are you convinced?
Yes, ma'am.
Okay.
Yes, ma'am.
A quadratic polynomial having 4 and 3 as zeros is x square minus 7x minus 12. So if it is 0, sum should be minus 7 and the product should be minus 12. If the sum is minus 7 and the product is minus 12, what are the numbers? We need to find two numbers whose sum will be minus 7 and the product will be minus 12. If the product is a negative number, one of the numbers should be positive and the other should be negative. Can you find such numbers whose product will be minus 12 and sum will be minus 7? 3 and 4. Try minus 3, minus 4. But the product will be plus 12. So that is not the number. Then
Minus 4, minus 3.
no dear, minus 3 and minus 4. When you add, you get minus 7. But when you multiply, same sign, you will get a positive number. But we need product is equal to minus 12, isn't it?
Minus 4 and 3.
Minus 4 and 3 will not be the answer because the sum is negative 1.
6 and minus 2.
Okay. 6 and minus 2. 6 plus minus 2 will be positive 4, not minus 7. Bazinga.
That is negative or false.
Negative? Come on, try. We can try now, not on the exam time. Exam, we need to be like thorough. By now, you can try. All of you can try, no problem. We can make mistakes now also, but not later on the exam. Yes. So, are you able to find that this 4 and 3 are the zeros?
No.
No, no. So, the first statement is true or what? That's what we need to find out. We don't have to waste our time by finding the right roots. Understood? We just need to stick on to the question only. Otherwise, we will be like gone to other level and we will waste our time. So, always stick on to the question. Okay, during the exam, please keep it in your mind. Answer to the question only. What is the question? A quadratic polynomial having 4 and 3 as zeros. Or you can even write how? X square minus sum into x plus product. So, it will be like x square. Sum will be 7x. Product will be 12. So, it is x square minus 7x plus 12. Am I right? Isn't it the quadratic polynomial we are supposed to get? X square minus 7x plus 12. But what is the polynomial given? Minus 12. So obviously S1 is wrong. The quadratic polynomial having alpha and beta as zeros is given by x square minus sum into x. This is correct only. That is the theory. That is the actual fact, right? So second part is correct, but the first part is wrong. So we will pick accordingly. Clear? Charles, are you there? Is that clear? Remo, Mariam, Philip. Are you there? Abhinav, Alan? Okay, hi. Is that Remo or Mariam or Philip? Who is in the class? Okay, next question is zeros of the function. That is a polynomial is given x square minus 4x minus 5 are 5 and minus 1. Okay, zeros are given. So is it right? X square minus sum of roots into x plus the product. Let us try that. So x square minus sum of these two numbers is 4x plus the product will be minus 5. Yes, it is. Correct only, right? So first part is correct. Next one is the polynomial whose zeros are 2 plus root 3, 2 minus root 3 is. So let us try x square minus sum 2 plus root 3 plus 2 minus root 3 into x plus product 2 plus root 3 into 2 minus root 3 is in the form of a plus b into a minus b. So it is a square minus b square. So 2 square minus root 3 square. Now it will be like x square minus root 3 and minus root 3 get cancelled. It is minus 4x plus 2 minus, no, 2 square is 4. 4 minus 3 it will be, which is 1. Am I right? I got 4 minus 3. A square minus b square. So x square minus 4x minus 7. So is it a right statement? No, na? So second statement is wrong. So this is the quadrant. So the same pattern only. So it is kind of repeating. Now alpha and beta are the zeros of the polynomial x square plus 2x minus 15. Then 1 by alpha plus 1 by beta is 1 by 25. Now we have x square plus 2x minus 15 where alpha plus beta is equal to 2. Alpha into beta is equal to minus 15. Right? Sum is equal to 2 and the product is equal to minus 15. So the numbers are 5 and 3, whereas since the sum is a positive number, bigger number should be positive and the smaller number should be negative. Okay. Now we have the alpha and beta. So the numbers are positive 5 and negative 3. So alpha and beta are 5 and minus 3. What do we need is 1 by alpha plus 1 by beta. We need to check that only. So 1 by alpha plus 1 by beta is equal to 1 by 25. We need to check whether it is equal to 1 by 24 or not. 1 by 25 or not. When we have 1 by alpha plus 1 by beta, take the LCM. What is the LCM? We are going to add them. So the LCM will be alpha into beta and the numerator will be beta plus alpha, which is none other than alpha plus beta only. And what is alpha plus beta? The sum of the roots, which is 2 here, divided by alpha into beta is product of the roots, 2 by minus 15. Is that equal to 1 by 25?
No.
So when you see 1 by alpha plus 1 by beta and all, please take the LCM. You will get in terms of alpha plus beta and alpha into beta. That will be given. Or we can write from the given quadratic polynomial. Alpha plus beta is sum of the roots. Alpha into beta is product of the roots, which we can write using the coefficients. So once you see, remember, once we see 1 by alpha and 1 by beta, you just take the LCM and add. It is none other than 1 by alpha plus 1 by beta is none other than alpha plus beta by alpha beta. Clear? Okay. Now what we have? If alpha and beta are the zeros of the quadratic polynomial ax square plus bx plus c, then alpha plus beta is equal to minus b by a. Yes, they are correct. They have given just a statement which is true. Next. If one zero of the polynomial is reciprocal of the other, then k is equal to 6. So we have alpha and beta are the roots or zeros. Now alpha is equal to 1 by beta. So we can write that it is beta and 1 by beta, or you can even write it as alpha and 1 by alpha. That means there are two roots for this quadratic polynomial and one is the reciprocal of the other. So you can take it as alpha and 1 by alpha or beta and 1 by beta. Okay, now what we have? Now we need this quadratic polynomial is there. We have alpha plus beta is equal to, sum is equal to what? Minus b by a, which is k plus 18. And what we have? So alpha into beta we can take now. Alpha into beta. Product will be c by a. C is 4k by a is coefficient which is k plus 18. Okay. Now I will stick on to the product of the roots. Why? Because our roots or our zeros are reciprocals. So alpha into beta is c by a. I hope this part is clear. 4k by k plus 18. I am sticking on to that product part because the roots are the reciprocal. So I will take alpha into 1 by alpha is equal to 4k by k plus 18. Alpha into 1 by alpha is 1. So 1 into k plus, so 1 k plus 18 will be taken to the other side. So k plus 18 is equal to 4k you will get. Rearranging 4k minus k. 3k is equal to 18. Therefore k is equal to 6. Yes, it is correct. Understood? One root is reciprocal of the other. So we can take the product. When you multiply with the reciprocal, you will get 1. That we know. And it is easy to solve and find the value of k, and we got it as 6. You don't even have to go to the sum of the roots. This is fine. Clear? Next is x minus alpha and x minus beta are the factor of the polynomial p of x. Then alpha and beta are the zeros of p of x. Same only, no? The factors are there, x minus alpha into x minus beta. Then alpha and beta are the roots. So this is, both are correct. Okay, I'm going to the next question. This is a nice question. If the zeros of x square plus px plus q are consecutive integers m, then p square minus 1 is equal to 4q. If they are consecutive integers, they have given that. Now we can have is, look, this is a quadratic polynomial, x square plus px plus q. If the roots are alpha and beta, but these are consecutive integers. Consecutive integers means what? Alpha plus 1 will be beta. In order to get the next integer, you just add 1. Or you can write that alpha minus beta is equal to 1. Right? Alpha minus beta is equal to 1. Now, we need to find what is p square minus 1. Now, if I am taking the sum alpha plus beta, sum is equal to minus b by a, which is minus p. Alpha into beta, the product is equal to c by a. So, I will get it is equal to q. Now, I have alpha plus beta is equal to minus p. Alpha into beta is equal to q. Now, when you have alpha plus beta, alpha minus beta, alpha into beta, and you are having p square minus 1, p square minus 1. What is alpha? Alpha minus beta into, do we have to even multiply that? Now we need to find what is p square minus 1, that is equal to 4q. Now for that, let me remind you this. A plus b the whole square is a square plus 2ab plus b square. I can even write a plus b the whole square is equal to a plus, or a minus b the whole square. What I will get when I am doing a minus b the whole square? I will have a square plus b square minus 2ab. In order to make this equal, I need to add plus 4ab. Plus 4ab. So this is an identity. So let us try if it is possible over there. A plus b the whole square. That is alpha plus beta the whole square. Alpha plus beta the whole square is equal to alpha minus beta the whole square. Alpha minus beta the whole square plus 4 times alpha beta. I am using that identity. Are you getting my point? We have an identity and I am using, instead of a and b, we are using alpha and beta. Now we have alpha plus beta, which is minus p the whole square, minus of alpha minus beta the whole square. I am taking alpha minus beta to this side. Alpha minus beta is what? 1. 1 square is equal to 4 times alpha into beta, which is q. That is positive p square minus 1 is equal to 4q, which is correct. Right? Understood? So remember that we have this identity. So please keep it in your mind. This is going to help you. These identities are going to help you. You can use that also sometimes. For alpha and beta, 1 by alpha plus 1 by beta, please take the LCM. When you see alpha plus beta, alpha minus beta, alpha into beta, please use this identity. You try to use this identity. Okay, then you can find some kind of connections like this. Now look at the next one. Next part is x minus a into x minus b minus c. Alpha and beta are the zeros of x minus a into x minus b minus c. If these are the zeros, if these are zeros of this one, you can write x minus a into x minus b is equal to c. Okay, minus c. No, it's not, it is equal to c. Now, x minus a into x minus b minus c. This is a quadratic polynomial. When you open, you will get a quadratic polynomial. Alpha and beta are the zeros. Now, a and b are zeros of x minus alpha into x minus beta plus c. That's what we need to find out. Or we need to check that one. Okay. What is the meaning x minus a into x minus b minus c? That means if alpha and beta are the roots, you can write alpha minus a into alpha minus b minus c. Also beta minus a into beta minus b minus c. This will be equal to 0. Or when you have a quadratic polynomial, okay, how do we write a quadratic polynomial when you are having roots alpha and beta? You can write it as x plus alpha into x plus beta. When these are the factors. Now how can we connect this? Alpha and beta are the zeros. And they are zeros. Alpha and beta are zeros of x minus a into x minus b minus c. Now for values, x minus alpha, then a and b are zeros of x minus alpha. Okay, I'm getting stuck. Okay, help me. How can we do? Since they asked me to wind up, I just got stuck. Like x minus alpha and x minus beta plus c, we need to find, the quadratic polynomials. Okay. If alpha and beta are the zeros. Maybe I will continue the question in the next class also. Is that okay? Because the next class is in Q. Okay, we will do, actually we had one case study also to discuss. But I think we will quickly revise this also and we will go to the next chapter. Okay? Okay. Okay. I need to check this one also. There was a little bit tricky concept to complete this one. X minus a into x minus b minus c. Then a and b. Actually, this is a true statement. Alpha and beta are the zeros of x minus a into x minus b minus c. Then a and b will be the zeros of this one. That was a true statement only. But the reason now I am not getting that out. I'm getting stuck. Okay, I'm really sorry for that. Then we will see in the next class and we will continue this one. Okay? Okay, bye.
Okay. Thank you.
Okay, all of you study well and we will see. Bye.